to use Arduino and also program 3 degree of freedom manipulators. So here we have a 3D printed 3 degree of freedom manipulator. So it's almost like an elbow manipulator that you have studied in your class. So what we are going to do today is we are going to program the motors of this manipulator to follow a trajectory. So you will give the initial position such as an angle, and then you will provide the time so that the manipulator will move to that particular angle in the given time. So that's what you guys must have done in the previous class in your 5th chapter, path and trajectory, right? So before we actually do this programming, I'd like to go over the basics of the Arduino. Is there anyone here who already has done programming in Arduino before? Just few? Alright, so it shouldn't be complicated, it is very straightforward. We use C language, and if you take a look at the Arduino kits, I'm assuming that you already have one at your desk. No? Yeah. Okay, so take a look at the Arduino kit. I'm going to explain how we are going to connect the pins and how we are going to program this. So if you take a look at this one, you will notice that there are 2 sets of pins here. So hold the power cable towards the top, and then on my left side you will see one set of pins, and then on my right side there are again another set of pins. So the left set of pins are called digital pins, and the right set of pins are called analog pins. So with their name, I think probably you must have already got an idea that we can connect any components that use digital signals to the left set of pins and the analog signals to the right set of pins. So what is digital and analog? Students from electrical engineering, come on. Difference between analog and digital signals. Okay, an analog signal is nothing but a continuous signal. So when you are talking about voltage here, Arduino works on 0 to 5 volts, so it's that range. So analog signals generate voltage between 0 and 5, so you can set it to 1.5, you can set it to 2 or 2.5, 3, 4 and 5. But when you are talking about digital signals, there are only 2 states. So either you can set the value to 0 or 5, but not in between. So there are only 2 values for the digital pins, and there are continuous values for the analog pins. And where do we use these digital pins and analog pins? When you are trying to read the sensor values such as temperature sensor, light sensor, or measuring a distance between an obstacle, you will be using analog because you will be getting the values based on the varied voltage. For example, if there is a temperature sensor that is connected to the analog pin, you will be reading a different voltage which is slightly greater than or less than, let's say, 1.5 or 1.7. So you will be able to read those fluctuations. But if you connect that to the digital pins, you will not be able to read the changes in the voltage because, as I said, there are only 2 states. Either it is on or it is off. So coming to the servo motors, we are going to use the digital pins on the Arduino kit. But if you take a close look at the digital pins, you will notice that pin number 11, 10, 9, 6, 5 and 3 has a tiny mark before the number. So those pins are actually called pulse width modulation pins. So they are digital pins, but they are also called as pulse width modulation pins, using which you can send a specific pulse of signal to set an angle of a servo motor. I'm not going to go very deep into this, but make sure that you are connecting to any of these pulse width modulation pins. Make sure that there is a symbol, a tilt symbol before the number. In this case we have 11, 10 and 9. So if you connect to, let's say, pin number 12 and 8, these servos won't work. Okay, let's make that clear. So everyone should have this software installed on their computers. This is called Arduino Sketch, and it uses C language. And there are some basic things that we'll go right now. So we need to have 2 important functions. The first function that you're going to see here is, I'm going to erase this and do it again. So the first function is void setup. And then the second function is void loop. So when you start the Arduino programming, the void setup will execute only once, and the void loop continuously executes as long as there is a power in the Arduino kit. So let's do a demo program here. What I'm going to do is I'm gonna create a variable for pin number 13 on your Arduino kit. So the way that you define variables is give the data type. In this case, this is integer, and then I'm gonna call this pin, which is just a name, and I'm gonna give the value 13. So here 13 is stored in the variable pin, and for the first setup, I need to set the pin mode to output. Pin mode, pin output. So the reason why we need to do is these digital pins can either read the data or write the data. So in this case, I'm trying to write the data. That's why I actually set the pin mode to output. So that's just our initial setup. And then now we are in the void loop, which will be executing continuously. So what I'm going to do here is I'm going to use a function called digital write. So digital write actually sends a signal to a given pin, and there are two signals that you can send: a high signal or a low signal. So let's see what happens here. So the function name is digital write, and notice that here W is capital. And then the first argument that I'm going to pass to this function is the pin variable, which is pin number 13. And then I'm going to set this to high. And then I'm going to again set this to low. So I'm continuously sending a signal of high and a signal of low to pin number 13. But in order to see whether the signal is properly sent, I'm going to actually include a delay between these two signals so that we can see with ourselves. So I'm going to send a delay of 1000 microseconds, which is milliseconds, which is nothing but 1 second. So once the code is completed, all you got to do is connect the Arduino to your computer using the USB cable provided, and then use this icon right here that says upload. So currently I am not connected yet, but let's do it once. Okay. So I connected the Arduino using the USB cable, and I'm going to upload the program. So once the program is done uploading, then you will be able to see a message right underneath here. It's still uploading. Okay, so here the uploading is done, and if you can notice, maybe it's very hard for people on the right hand side, you will notice that there is a LED light that is blinking with a gap of every 1 second. So I'm going to keep this as a workshop instead of having as a lecture, so that I can come to each of your desks and we can go over there. It will be a little hard because you cannot see the Arduino that I have over there. So if you have any questions in this program, just ask me right now.
It's getting an error.
What is the error again?
Problem.
Expected unqualified ID before they should check the port.
Okay, so click on the tools right here, and then go to the port. Select the Arduino COM4. In this case, it might be different for you.
In my sign up, it's showing only COM3.
But it's still Arduino, right? Do you see Arduino next to the COM?
Only COM3 is there.
Then your Arduino is not detected actually. Can you unplug and plug it again?
Yeah, sure.
So if the program properly is uploaded to the Arduino, you should be able to see an LED near pin number 13 that blinks every 1 second. You don't have an Arduino kit here?
I do, but I don't have the part.
What's this?
You already installed it, so it's deleted.
No, you need to do it again. I think when you connect to the power, it already runs the program. Upload again. Okay, I think change the delay over there. Currently it is 1000, right? Change it to maybe 500 and see if the rate at which it makes the changes. You have an extra one? It's 500 now?
Yeah.
Faster? Right. Yes. Because your W is small. It's a capital W. Working here? Can you change the delay to 5 in operation? Oh, you're operating there. Is anyone having issues? Were you able to upload the program properly? Is everything okay?
Yeah.
It's working?
All right. Since the program is working for everyone, let's move on. Let's try to actually connect the servo motors to the Arduino kit. So everyone should have a set of the ARM with you. Can I use this for explanation?
Oh.
I'll leave it. So take a look at this manipulator. You will notice that there are again 3 servo motors, and each servo motor has 3 wires. So the red color wire here is the positive connection which we are going to send the 5 volts, and then the brown color wire is the ground. So in your Arduino kit, there is a way to send power to this servo motor. On your right set of pins, you should be able to see 2 values called 3.3V and 5V, and there should be 2 pins that says G and D. Were you able to find it?
Yeah.
So we are going to use the 5 volt pin to send the power signal to the red color wire to any of these servo motors, and then we are going to use the GND pin, which stands for ground, and connect it to the brown color wire. So the way that you actually do it is use these cables, which will be provided to you soon, jumper cables. So put one end of the jumper cable to the let's say pin number 5. Yeah, you can explain. 1 second. So just for the reference, I'm gonna actually use the red color jumper wire and connect it to the 5 volt pin here, and then use this yellow and connect it to the ground. And then I will need one more wire. In this case, I'm just choosing a green color. And remember that I told you that we need to use a pulse width modulation pin in order to send a signal. So these are the power cables, and we need one more signal cable, which is on your, let's say, if I hold it this way, on your left set of pins. So I can use pin number 13 in this case. So now I have 3 wires properly connected. I have the power, I have the ground, and I have the signal. So I can connect these 3 pins to one of the servo motors. So the same way, I can connect the ground to the black wire here, sorry, the brown. And then the red one goes to the red one here. And then the green, the signal cable, will be connected to the orange one. So this should be your initial connection. This I just connected for the first servo motor, but we will use a breadboard soon to connect the different servo motors. So basically that's how we connect 3 servo motors. We'll get to that, but make sure you do this connection first. If you have any questions, just raise your hands and we'll be there to help. Okay. I'm coming with some jumper cables here just in case if you need. Oh, there's one more here. Alright, make sure that you connect the red color wire on the servo motor to the 5 volts, and the brown color one to the ground, and the orange one to the pulse width modulation pin on your digital pins.
No, it doesn't. You have 2 times. This is a control. It controls servo motors through this wire.
So those are the colors again. If you have any confusions, take a look at the board. Alright, let's take a look at the program so that we can test the servo motors. Okay, are we ready? So red is for the 5 volts, and then brown is for the ground, orange is for the pulse width modulation pin. You can use any of the PWM pins.
Where is the pulse?
So on your digital pins, you should be able to find a symbol next to an analog. So,
That's all. I'm gonna use Bridgeport. So we have one.
okay.
So we want power for all of it.
All right. Let's test the connection. Take a look at the program here. It should be fairly simple. So again, we are going to use the setup and we are going to use the loop, but the only difference is we are going to include one library called servo.h, which is nothing but a header file in C language. So we need to first include servo.h. Okay, that should be your first line. Once you include servo.h, we need to define a variable for the servo motor. The same way how we defined for the pins before, I'm going to create a variable for servo. I'm going to call this servo S1. So in the last program, we have actually used the setup function to set the pin mode to output. In this case, we are going to attach the servo to a particular pin. For example, let's say if you are using the pulse width modulation pin number 11. Okay, what are you guys using here?
13.
13, right? So you need to attach the pin number 13 to the servo variable here S1. So I'm going to define a variable here. I'm going to call this servo pin. So for an example, I'm going to use that. Is 13 pulse width modulation pin?
No.
No?
11, 10.
Right, we cannot use 13 over there. So make sure that you can use, I think, 11, 10 and 9, any of those. So I defined a servo variable and I defined a servo pin. And then here in the setup, what I'm going to do is S1 dot attach servo pin. So once this setup executes, it understands that pin number 11 is for the variable servo 1. So once that is completed, then you can do S1 dot write, and then you can provide an angle here as a parameter. So in this case, your servo cannot go more than 180 degrees or less than 0 degrees. So you can provide a value between 0 and 180. So let's say 90 degrees. And I'm going to give a delay of 2000 milliseconds, which equals to 2 seconds, and then I'm going to again write 145 degrees, and then provide a delay of 2000 milliseconds. So currently I don't have an Arduino kit here, but if you properly execute this code and upload it, you should be able to see the servo motor that you have connected should rotate to 90 degrees and 145 degrees with a gap of 2 seconds.
I think they need to add the servo library first.
Yeah, we did add already.
No, I need the actual file.
Does the software already include it? The servo.h. This is good, it works.
No, someone is inbuilt library.
We close the old file that we uploaded. You can edit it if you
By
want.
default,
Just add this to it.
Yeah, just edit that.
None of those wires. You look down here. You could use that breadboard. I gave you 9 numbers.
Make sure that you include the servo.h on the first line, and then define a variable for the pin, define a variable for the servo motor. And in the void setup, we are going to attach the servo variable S1 to the pin, and in the loop, we are going to set angles to the servo motors. Is it more?
So,
In the
You can give us the
define it.
Everything can be done through program. We are just doing basics right now. But
So it's working on a program.
so test with other joints as well. That's joint one, right? So try other.
At the beginning it's 90 degree. Then after 2 seconds it will go to the 1.
So test each and every
So
joint.
this is the 90. This is the 1. So it's good. Yeah, it's good.
Test the other joints as well. Okay.
So now we can have, using the program we can have where is the power? So we can just attach it to the so all this line are the power. So I can attach it to any motor. It's better to do it yourself. I already have experience in this.
Is everything okay? This, what is it? Servo Pro.
It's, I think it doesn't matter. No, this is the ground. So this is the ground.
Try to change the angles and try to change the delays and see how the servo motor actually rotates for your program. Okay? Yeah. So try with different angles and try with different motors as well. So we are actually working on the Arduino programming. So we need to
have
work with
3 motors. One more? Yeah, because we have 3 motors. 1, 2, 3.
smooth.
1, 2.
Try for other motors and different angles and different delays.
Add the one more.
No, we can remove the previous one.
We can add
We can do it, but not right now. We need to use the breadboard. For that.
Because you do, yeah.
All right, so okay, let's actually do the multiple servo motor connections here. Everyone, please take a look at the breadboard. Does everyone have a breadboard with them? Okay, so if you have a breadboard here, take a look at the alphabets numbers that's on the breadboard. So here you can actually see there are 2 lines on your left and right side. You can call them power lines because if you connect to one of the pins to that power line, you will be able to draw the power from the entire set of pins. So if you want to connect, let's say 3 servo motors, you need to use 3 5 volts, but unfortunately in Arduino you only have 1 5 volt pin, right? So use that 5 volt pin and connect to the plus sign set of pins right here. So on your Arduino, use the jumper cable, connect the 5 volts on the Arduino set, and then also use the breadboard here this way, and then where it says the negative, connect the ground. So you should have 2 wires going through the power line right here. Positive and negative should be connected to the Arduino 5 volts and the ground. And once that is done, can I get more?
As a controls, because we have one here and the other 2. Try to select the one with the no tiny sign. 10 and 9.
Why is that?
This is so you can
There is no
have
reason.
one something. try to make them in order. So this is 11, so this is, should be 10 to make it just easier on the program. Actually, I'm an engineer. So
Alright, here is a rough diagram for Arduino and the breadboard. So
and we done
take a look at this diagram here and take a look at the positive and the negative lines on your breadboard. Use the positive 5 volts and connect to one of the ports at the plus symbol, and then use the ground and connect to the negative
two more
here.
circuits.
So once you connect that, you can use any of these pins to use the 5 volts for your servo. So if you have, let's say, 3 servos,
No. This is just once. This is a
so
library.
you can use the positive line from this to servo 1, and again from here to servo 2 and servo 3. So you can do the same using the ground.
Yeah, and the edge.
So that's how you can actually power your 3 servo motors using the breadboard. So raise your hands if you have any questions. We will be able to help you.
But you cannot have the same variable. You need to choose
So in BF1,
two. Make it two. Referring to the motor. And this is one.
but then I need to change this to
Yeah, of course. We need to add one more. Three.
Are you clear with the connections?
Yeah, we are.
Oh, okay. Any questions? Yes. So I should be ready for the question.
So we need to attach the pins to the motors.
You can take it, right?
You can pause the videos and continue.
Just to convince the